Virtual LANs. By design, network hosts connected to the same local network topology, whether by means of an access point or switch, can pass traffic back and forth transparently. Often, a flat, transparent network topology can be undesirable, especially if users with different access privileges, such as guests and admins, send and receive data on the same LAN. By contrast, virtual LANs, or VLANs for short, logically divide a local network topology in order to isolate traffic to separate broadcast domains. Conceptually speaking, deploying two different LANs is the same as configuring two different VLANs on the same hardware. However, virtual LANs consolidate hardware like in a router on a stick topology. In this example, 3 hosts connected to the same switch can reach each other via broadcast. However, once assigned to a VLAN, hosts can only broadcast to other hosts in that same VLAN. InterVLAN traffic, therefore, requires a router or a Layer 3 switch, capable of moving packets between networks. According to 802.1q, the industry standard for virtual LANs, network traffic receives VLAN assignment through tagging. More specifically, the header of a Layer 2 frame receives a specific tag, or VLAN ID, representing the VLAN to which the tagged traffic belongs. In general, most vendors, including Ubiquiti, use VLAN 1 as the default VLAN, so network devices and protocols communicate and work out of the box. However, today's Layer 2 network devices all support 802.1q for traffic tagging, where host packets receive VLAN assignment. Because host traffic in VLAN 10, 20, and 30 is tagged with their respective VLAN IDs, VLAN hosts can only broadcast to other hosts within their virtual LAN and not to hosts in other VLANs. In order to tag traffic, that is, work with VLANs, interfaces and ports receive port VLAN assignments, or PVID for short, and classify as one of 2 port types. Access ports connect to host devices and therefore have a single port VLAN ID. On the other hand, trunk ports connect to other trunk ports of VLAN-ready devices like switches and access points and can receive as many port VLAN IDs as are required per the network topology. To help illustrate how VLAN tagging works with traffic, consider the following. A host sends traffic upstream without tags. The untagged traffic reaches the access port, at which point the access port inserts the VLAN ID, or the tag, into the frame header. With the VLAN tag now in the frame header, trunk ports recognize which areas of the Layer 2 network should carry the VLAN traffic going up or downstream. As tagged traffic moves downstream, the access port removes the VLAN tag from the Layer 2 header so that the host receives the traffic untagged, that is, without the VLAN ID. Trunk ports can also carry untagged traffic if desired, but only one VLAN ID can and should be assigned to the untagged traffic. And like all traffic destined to non-local networks, InterVLAN traffic must be routed through a local gateway. To clarify, InterVLAN traffic must be routed for 2 reasons. At Layer 2, each VLAN represents a separate broadcast domain, while at Layer 3, each VLAN receives a unique network IP range. Similar to how switch ports and access point SSIDs receive PVIDs, a router can be configured with virtual interfaces to participate in a virtual LAN.